Okay, welcome back. We're on page 615 talking about a cautionary tale about non-working prototypes and how some people just don't get it. Okay, so prototyping system is fantastic, particularly if you cannot articulate the requirements. There is another approach called Agile. And Agile is designed for those scenarios where perhaps my goal is a little confusing, like the example of I want it to be gorgeous. What the heck does that mean? How do I know if I've met that? Well, the only way to really do that is to have some sort of iterative process. So I'm showing the users, and I have a tight relationship between the people that are doing the development and the users. Essentially what I do is I'm the developer guy over here, and I'm borrowing this employee several times a day. Maybe even the employee comes and sits next to me during the design. And so I'm designing this thing and I'm turning over to the guy and says, "Is this what you guys had in mind?" The guy says, "Yeah." And so I'm working as a team with a team of programmers and a team of potential users. Okay, now this is a fantastic system for getting precisely what the user wants. Okay, if the user wants something gorgeous, that's kind of sort of difficult to quantify, isn't it? The way Agile works is I have a team of developers, a team of users, and we work collaboratively together, and whatever we come up with is probably what you wanted. That's how you describe gorgeous, is everyone gets together and decides, yep, that's gorgeous. Great, let's move on to the next thing. Okay, now, all is not well in Agile world. First of all, when I go borrow a person, that's kind of a detriment to the organization, right? I mean, unless you just happen to have spare employees hanging around. Most likely that person's got a real job, and I'm taking them away from their real job, and probably for quite some time. And I'm probably not taking a junior person away from their job. I'm probably taking like one of the most senior people away from their job, okay? So, that's a little tough. And also, let's say that this is a typical office environment and most of the users are relatively high-tech, or perhaps this is a high-tech organization. You know, like you're a business and you're making, you're making routers for a living. Okay, so it's already kind of a high-tech organization. You know, you have design engineers and network engineers and lots of people who are kind of in the software business. And so you're designing a system for them. They're going to have quality people that can communicate on the same terms as the developer. You have a stable of people over here you could pick. Okay, but what if this was a steel foundry, okay? And I go down to this cradle operator and I say, "So, what do you think about this form?" He's going to say, "I don't know what the hell you're talking about." You know, so if it's a low-tech organization, then perhaps the users are not going to be at the right level to be able to communicate with a developer. So Agile works very well if it's a high-tech organization and you have lots of high-quality people you can talk to. If you don't have high-quality people you can talk to, well, then you're kind of sort of not in a good mood to use Agile. So Agile is great, but I got to have spare people. That's tough. No, that's a burden on the organization. Can you imagine going in and say, "Okay, I want to borrow your 3 top people for a month to help me work on this project"? And they'd say, "Sure, go right ahead." Or are they going to say, "No. This is your project. You need to come up with your own damn people. Don't pester my people." So some environments, for example, I can't imagine the government would say, "Sure, go right ahead." And most likely the government is going to say, "Look, it's your job to do the design, not us. We're not designers. You know, we're the customer. Leave us the heck alone." So Agile is special. Agile does produce fantastic products, but we've got some interesting things going on. Here's the life cycle. So I come up, I hate these stupid things. Well, okay, look in the book. Anyway, in fact, why don't we just move on to the next figure, talking about the advantages and disadvantages. So, for appropriate projects, this approach produces application and production sooner. It's most likely going to be relatively quick. The documentation is produced as a byproduct of completing a task. Okay, cool. Agile forces teamwork and lots of interactions between the users. Now let's look at the downside. Agile requires large percent of stakeholders' time than any other approach. If you can handle that, you're a good candidate for Agile. If you're already swamped, and let's say it's at the end of your fiscal year, and your top people just don't have the time, then Agile is not going to work for you. So this approach requires systems analysts to be skilled. Okay, so in other words, high-tech people, right? We're not talking about just Joe user off the street. And this intense SDLC can burn out people because it is pretty doggone quick. So, you know, it's not like a slow, leisurely pace. This is an awful lot of stuff going on. And it takes high-quality people on the team, on both sides of the team, you know, the programmer side and the vendor side. Okay. So, it's not for everyone. If I was Apple, for example, and I was producing the new version of the Mac OS, oh, you bet your ass I'd do this, okay? Because I want it to be gorgeous and I want it to be perfect. Okay, I would definitely do it. But if I'm producing, you know, a new, let's say I'm producing overhead cranes, okay, I probably would not. I'm not going to be asking too many crane operators on you know, the placement of buttons. Yeah, probably not. Extreme programming is not really a third category. It's just talking about having people work in teams. And you basically have a weeds person and a trees person. So one person is deep in the weeds and one person is looking at the forest. You know, so detailed, big picture. That's what it's all about. So as one person is working on the details of how I'm doing work, you have another person on the team and they work together. And this person basically says, well, okay, that's fine and good, but how in the world is that going to meet this requirement? You know, they're looking at the big picture. So big picture and small picture is what that's all about. Okay, so let's look at the three types that we talked about. So traditional. So this is a sequential thing. It's a waterfall. Typically, you don't have much opportunities to go back up the waterfall. So sequential, and basically you have to wait until one phase is done before you can go to the next. The basic assumption is that all critical requirements can be defined. Okay? If you can define the requirements, SDLC works just dandy. How requirements are defined? Well, the users interacting go through and say, here's what it must do. And the associated process is, you know, a structured design. So prototyping. Prototyping is some sort of an iterative process. I show them this, they go, yeah, but. And why? It's because the system requirements cannot be defined. Now, it could be that could not or absolutely, positively impossible to. So, most likely, the problem is that the user cannot articulate the requirements. Okay? They just can't do it. So, how are the requirements defined? By just giving them things over and over and over until you just stumble across what the requirements are. Because they are not going to tell you what the requirements are up front. You're just going to have to discover them along the way. And so this is fairly rapid. Okay, Agile. It's an interactive process. You work in these little tight groups, maybe for like 3 or 4 weeks at a time. Then you stop and produce. And then you show them, okay, here's where we are so far. What do you think? And this could get out of hand. I have seen Agile projects that kind of went off in one direction. And then they went, you know, that's dumb. Let's go back. So they went off in this direction. And they ended up throwing away a lot of work because, you know, they went off on a tangent and finally said, you know, that was dumb. Let's go back. So everybody goes back. System requirements cannot be defined at the start of the project. Yep. Users interacting with the system analysis and working software. And Scrum is just a technique where everybody gets together in a huddle. Okay, it's not a real programming. Although, I guess it kind of sort of is a programming term. Okay, so that's what that is all about. So, this is kind of an important slide, hint, 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 because it talks about the pros and cons of each approach. And it's really all about, can I articulate the requirements, yes or no? Okay. I'm going to skip over a couple of things in here. I'm not going to talk about object-oriented system development. You guys aren't necessarily developers, so that's kind of a dumb. I'm not really going to talk about mobile because, once again, you know, you aren't developers. And so, yeah, there's a big push, obviously, and most everything being developed now has a mobile component to it, right? Okay. I am going to talk just a tiny bit about what happens if your own users do development for you. Okay. So you have an office environment, and you got somebody who's an electrical engineer, okay? He's sitting over in the corner, and he's designing this new electrical distribution system. He's a high-voltage electrical engineer. Cool. But he also happens to be a hobbyist programmer. So he whoops out some application for you that all the rest of the engineers in the office are using. Is this good? Yeah, it's good. However, what, how much user documentation do you think I'm going to get? Probably none. How much support? I mean, this one guy is supporting everyone? What happens if that guy leaves? Do you just give up on that piece of software? You just keep on going the way it is? So this causes a lot of problems with IT staff. I like the idea that users can go in and do their own thing. I like that, but user developed systems subject to the same reliability, performance, quality issues as ones that are developed by professionals. The only problem is that these guys are probably going to be a one-stop shop, and when they leave, there's no one to go to and say, well, this function didn't work. And you go, too bad. That guy, Bob's gone. Tough. Okay. This next section is talking about, in general, what problems do you typically have with projects? And so I kind of sort of like this. There's a list of things here of where projects can fail. All right. So here's the most likely reasons why you could be building a bridge, any project. Obviously, we're talking about system development. So here we go. So business executives fail to provide leadership. In other words, they are apathetic. They don't care if this new system comes in or not. That is a recipe for disaster right there. If they don't have a vested interest and they're not passionate about this thing, no one else in the organization is going to be. And this system is going to, you'll produce a new system and probably nobody will use it. Okay, so this is tough. Part of the reason is these guys are the ones who set the business goals, this is that analysis. Remember, at the very beginning of the investigation, and this is the part, if you don't get right, you're going to end up lowering the shelves of the grocery store. Okay, remember that analogy? So if your business executives aren't there to tell you what the goals are, you're in bad shape. The scope of the project is unclear. You were never able to hammer down what the scope is. And let's stop for just a second and talk about a phenomena called scope creep. And that is, here's the scope. And then as you get into it, the scope gets bigger and bigger and bigger and bigger. And if you let this happen, your project will never be finished. Because you'll just say, oh, that's a great idea. Let's add that. And then the next guy comes up, well, that's a great idea too. Let's add that. And, it could be that, you're hiring this team and they're working, they're by billable hours and they have no vested interest whatsoever of saying, no, that's enough. They're likely going to say, sure, bring it on. Because that way we can just bill you more, right? They don't have an incentive to say no. So you do need to pay attention and you need to have some way of that formal change request, just like the maintenance request thing a little later on. But here it would be some sort of a formal change request process that has to be signed off. Somebody has to say yes or no. You don't leave it up to the guy you hired to develop this to say yes or no, because he'll never say no. Expectations were poorly managed. And this is the one I was telling you about. Let's say you went to a meeting and the guy said, well, I want these 3 things. And then you accept only one of these, but you never get back to him and say, recommendation 2 and 3 were disapproved. You never told him that, okay? He walks away thinking that all 3 of those features are going to show up. You implement the system, and he goes, where the hell are my features? You say, well, we approved one of them, but we disapproved the other. That's not the time to tell them that. You need to tell them up front what the expectations are. Insufficient user involvement. If your users aren't involved, clearly, you're not going to end up something that they want. The organizations just flat aren't ready for change. There are some organizations that are so stuck in their ways that, there's just not enough momentum to get them to move to the new system. And of course, poor planning. You don't have enough money, don't have enough staff, don't have the right time. And so this could end up with all sorts of nasty things. Okay, we have reached the end of the chapter. And quite frankly, the end of the class. The next time you see me, it will be a video talking about the final exam. Okay, see you guys next time.